Thank you. You are absolutely awesome. Welcome to our International Space Station Contact event. For those of you who don't know me, I'm Dr. Saylor, your superintendent. I really want to thank everyone who's been so helpful making this event a success. We've waited a long time to be able to get to this day, and a lot of expertise went into it. So with that said, I want to extend a special thank you to Mr. John Gazar, Mr. Brem, our ARIS team, and all of our middle school staff, students, administration, and extended community who put in time, resources, and a lot of effort to make today happen. Before we begin, and I know we're all excited to begin, I know I am, I'm really anxious, I can't wait to see this happen. I want to remind everyone, our special guests, to make sure that your cell phones are either turned off or on airplane mode. We want to make sure that they don't interfere with any of our live feeds or become a distraction to those around you. With that said, I'm going to turn this over to your principal, Mrs. Garman. She has invested countless hours coordinating this event, and I know there's probably no one here that's more excited to see you have this opportunity. So, Mrs. Garman.
Hello, students, staff, and friends of the Bellefonte Area Middle School. We are about to make history at this school as we attempt, for the first time ever, to put BAMs in space. This project has been a year in the making, and I have to say I am so incredibly proud to stand on this stage as the principal of such an amazing school. This has truly taken a team to make this happen. I want to take a moment to acknowledge some of those team members. First, we need to give a major shout out to the amateur radio team from the Nittany Amateur Radio Club, who built the equipment necessary for us to connect to the International Space Station. Those members include Woody Brem, John Gazar, Craig Miller, Sharon Geisler, Eric Prescott, Mike Koslow, and Bob Spooner. Please join me in a round of applause for their efforts. Next, I would like to thank some of our VIPs and our experts who are joining us today. Senator Jake Corman, State Representative Carrie Benninghoff, Tammy Ammerman from State Representative Mike Hanna's office, my fellow Bellefonte area administrators, and our panel of experts, Bill Syret, Chris Palma, and Jason Nichols. I also want to commend the staff and students of this building. Your enthusiasm is contagious, and your willingness to support at any time helped to bring this event together. I applaud all of you for your effort and for your team spirit today. There were also several school districts from across the state of Pennsylvania who submitted questions for this event. I would like to recognize the following schools for joining our mission. Hershey Middle School from the Hershey School District, South Fayette High School from the South Fayette School District, East High Elementary School and Elizabethtown Middle School from the Elizabethtown School District, Harrison Middle School from the Baldwin-Whitehall School District, Charles Boehm Middle School from the Pennsbury School District, Penns Manor Elementary School from the Penns Manor School District, Logan Elementary School from the East Allegheny School District, and Old Forge High School from the Old Forge School District. Thank you for submitting your questions and taking part in this program. We have a full schedule for you and quite a bit to cover before our contact occurs with our astronaut, Mr. Scott Tingle. So, without further ado, I would like to introduce Mr. John Gazar, a member of the Amateur Radio Club, as he directs us on the next path of our journey. Mr. Gazar.
Thank you, Dr. Saylor, and thank you, Mrs. Garman. So welcome aboard, and I have to agree with the sentiment of all the enthusiasm that I've seen in this school through the participation photos that have come into us, and looking at the hallways out here. The art class did a great job decorating. Overall, just a really exciting team effort. So with that, we will start with a little video to introduce the ARIS program. And excuse me, ARIS standing for Amateur Radio on the International Space Station. So the house lights will go down briefly, and we'll proceed here with our first video. Thank you.
Hello, space travelers, and welcome aboard. We're happy to have you join us today as we prepare to put BAMs in space. Today, we hope to highlight our journey by speaking to an astronaut in real time as their orbit passes
Hello,
overhead.
space travelers, and welcome
Before we
aboard.
get started, let us take a moment to recognize our sponsors for the event. Our primary sponsors for today begins with the Bellefonte Elks Post 1094, a place where neighbors come together, families share meals, and children grow up. The Elks invest in their communities through programs that help children grow up healthy and drug-free, meet the needs of today's veterans, and strive to improve the quality of life. Also sponsoring the event is Reliance Bank. Reliance is uniquely positioned to provide its customers with a special brand of banking while also being an active corporate citizen in the communities they serve. Together we will find a way is the promise they make to all they serve. Amateur radio operators Woody Brem and John Gazar, who encourage all to learn more about the possibilities that amateur radio can bring to your future. And the Nittany Amateur Radio Club, W3YA. This club is very active in emergency services in the area and participates in many public service events within our community and throughout the year. The club also mentors aspiring operators and provides ham radio testing for those interested in the world of amateur radio. Center Communications. With headquarters in Bellefonte, Pennsylvania, Center Communications is your one-stop shop for all your two-way radio needs. Our promise to you is a continued commitment to quality, service, ingenuity, and to personal attention. And finally, AccuWeather. Around the world, people trust AccuWeather to help them get more from their lives. Now then, back to the excitement of our students speaking to an astronaut as they orbit overhead aboard the International Space Station. This is made possible through a collaboration of more than 16 countries and at least 5 distinct space agencies. Our U.S. sponsors include NASA, the American Radio Relay League, and AMSAT US. These groups coordinate to form ARIS, meaning Amateur Radio on the International Space Station. Today, this is a virtual trip via amateur radio.
NA1SS, this is N2SJ, over.
NA2SJ from NA1SS for scheduled contact.
Hi everyone, I'm Tim Peake and welcome aboard the International Space Station, where we're orbiting Earth 16 times every day. One of the most rewarding activities that some astronauts undertake on orbit is to talk to schools using the space station's ham radio. Now these are events that are planned by ARIS, which is a worldwide group of amateur radio volunteers who are dedicated to introducing young people and students to science, technology, engineering and mathematics. Now this is the equipment here in the Columbus Laboratory, which consists of a handheld radio, a headset, and we also have a ham video unit. Now as the International Space Station orbits above your location, a radio link is established between the ISS and your school. Now because we're travelling at nearly 18,000 miles per hour, which is an incredible 25 times the speed of sound, we usually get about 9 or 10 minutes of good radio contact before losing the signal. So about 5 minutes before the scheduled start time of the contact, I come into the Columbus Laboratory and configure the radio so that I'm on the correct channel. And sometimes I'll set up the ham video too. Just before the predicted time, I'll begin to start calling the school using the standard amateur radio calling techniques. For example, if the call sign of your school was GB4 Fun, I would say Golf Bravo 4, Foxtrot Uniform November. This is Golf Bravo 1, Sierra Sierra, listening and standing by. Now at your school, the radio operator will be listening for my call, but may also transmit and try to call me as well. You'll probably have a much more powerful transmitter on the ground than we have up here on board, so I'm likely to hear you before you hear me. Then, once we can hear each other, then comes the best bit, which is actually talking to the students and answering the questions. Once I've answered all the questions, we use the remaining time to say goodbye to each other and end the connection. I'll then spend a few minutes configuring the radio back into a rebroadcast mode, and then I'll go back to my day job, which is of course doing science on board the International Space Station. ARIS is a brilliant opportunity for astronauts to talk to school pupils. It's really rewarding to hear how excited the students are when they're talking to somebody up here in space. And it's a true privilege to be able to inspire our next generation of scientists and engineers through amateur radio.
For the past several years, only about 60 schools on the entire planet were selected to make this journey each year. You are here today because the Bellefonte Area Middle School has earned the chance to make this trip. We hope today's event will introduce you to the wireless technologies involved in making this contact possible, and we remind you to dream big and work hard as we move closer to putting BAMs in space. In making this contact possible, and we remind you to dream big and work hard as we move closer to putting BAMs in space.
Okay, at this time, I would like to introduce to you our panel of experts and tell you a little bit about each one. Mr. Jason Nichols. He graduated from Linden State College in 1992 with a bachelor's degree in meteorology. He has been a meteorologist at AccuWeather for 24 years and has been the head of international forecasting for about 12 years. Prior to AccuWeather, he worked at a couple of smaller weather companies and has been forecasting the weather or has been an operational meteorologist for about 25 years. Next, we have Bill Siret. He was born in Bristol, Connecticut, and has been fascinated by weather that most people would consider bad since he was 5 years old. He was pleased and surprised to find lots of other weather weenies when he came to Penn State in 1980. He received a BS, a Bachelor's of Science, and a Master's in meteorology, and was then hired by Penn State as a research assistant, again in meteorology. In 1995, he began his tenure as the manager of Penn State's University Park Weather Observatory, now the Joel N. Myers Weather Center. He teaches several meteorology courses and enjoys contact with his students and all others with an interest in the weather. He's been a forecaster on a daily weather show, Weather World, since 2001, and his primary interests are general meteorology and weather forecasting. And last, we have Dr. Christopher Palma. He is an astronomer with an undergraduate degree from Penn State and a PhD from the University of Virginia. He is trained as an observational astronomer and has used many ground-based and space-based telescopes, including the Kitt Peak 4-meter, Cerro Tolo 4-meter, Keck 10-meter, Hubble Space Telescope, and the very large array of radio telescopes. His astronomy research includes studies of the motions of star clusters and dwarf galaxies orbiting the Milky Way and the gravitational interaction among galaxies. He has taught many different astronomy classes at Penn State, and these days is the head of the undergraduate program in astronomy and astrophysics. He also studies how students learn astronomy and has worked with teachers in State College, Bellefonte, Bald Eagle, and Penns Valley. Welcome to you all. If we could have our panel, please join us on stage. Okay, Colson, lead up your group. All of the students who are asking questions of the panel, Ivan, come on. Okay, welcome, gentlemen. We have 10 questions for you. You guys can decide how you'd like to answer them, okay?
Thank you.
All right.
Hello, I'm Colson from 7th grade, and I was wondering if you can see weather patterns in space.
Hi, Colson. Nice question. Anybody ever watch a nightly weather forecast on TV? Anybody? Okay. It's kind of like that. If you've ever seen a satellite image, yes, basically, if you're high enough up, you could see weather patterns from space. Anything to add?
Yeah, like you said, you can see from the space station and from other space vehicles, much like a satellite, you can see your tropical cyclones, and actually, if you know what you're looking at, you can actually see thunderstorms and lightning and everything from space as well. So,
Okay. Thank you.
Thank you.
I am Ivan from 6th grade, and have we learned anything new about like neutron stars?
So that's a great question. Let me say that unfortunately when we get questions like this, we often have to say the same thing, which is, so there's a new instrument attached to the space station that's called NICER, and NICER's job is to study these neutron stars, but it takes time. So the instrument was installed just a few months ago, and it's going to be monitoring these neutron stars for a really long time. So what we're going to learn, we expect to learn lots of great things about neutron stars, but it's going to take time for them to take the data, send the data back to Earth, people on Earth to analyze that data and figure out what it means. So my guess is we won't learn something new from that instrument for about a few years now.
Thank you.
Hello, I'm Melina from 8th grade, and I was wondering, how do the materials on the aircrafts, like the metals and wires, how do they resist the temperature changes?
Well, they have to carefully select the materials so that they don't, so that they can overcome the stresses and the big temperature changes that occur. Anybody here remember the Space Shuttle Challenger? There was a problem with the material, and it was a rubber seal to their fuel tanks, and because the temperature got so low before launch, the rubber lost its elasticity and didn't provide a good enough seal for the launch craft. When it went up, it exploded. So NASA is very careful to select objects that can put up with those stresses and temperature changes.
Can I add to that? I just want to add, so this type of research goes on at a lot of places, including at Penn State. And so some of my friends who have offices right next door to mine, they're going to launch a rocket that's going to go up above the atmosphere and be in space for just a few minutes.
Oh, wow.
They're not allowed to use a lot of materials that we would normally use. And so if you're going to build an instrument for NASA, you're only able to select materials that are what's referred to as have heritage in space. So they've been tested in space, made sure that they can survive in those conditions. And if they have that testing background, then we can trust them and we can put them on new rockets.
Cool, thank you.
Sure.
Davis Corman, 7th grade. How does the weather affect communication between the ISS and Earth?
well, for the ground-based antenna and stuff, they would be susceptible to lightning, wind damage, tornado damage, hurricane damage, but I'm sure there's enough redundancies that they could overcome that. Some of the bigger problems would be what they call space weather, where you can get solar flares and sunspots that kind of excite the ionosphere and could disrupt radio signals from getting from the Earth out into space.
Yeah, it's kind of neat because everything emits some radio waves, so there's a lot of signal between the space station and here. And so they have to direct that signal very carefully. And thick clouds or precipitation can decrease the strength of the signal enough so they can't hear anything. Okay.
Thank you.
Lydia Wenzel, 6th grade, and what are the requirements to be called a planet?
So, I could probably spend 2 hours just on this question. I will not go for 2 hours on this, but I'll give you the short answer. Words like planet, the original definition of planet included the sun and the moon. So the first time we talked about planets, it was the sun, moon, Mercury, Venus, Mars, Jupiter, Saturn. So Earth wasn't even considered a planet originally. And it just meant an object that moved on the sky differently than the stars. So then we discovered Uranus and Neptune and Pluto, and we called those things planets, including Pluto, because they move differently than the stars do. But as we've built instruments and we've learned more about these objects, we've learned that they're not all the same. And so Pluto, for example, just looks like a large ice ball, and there's many other large, rocky, icy objects like it out in the outer part of the solar system. So honestly, planet, that word, I want to stop using it because we've taken a word that was created hundreds of years ago and we're using it in a way that doesn't really work anymore. There was a definition that was come up with in 2006, but I don't like it, so I'll ignore that one. So I would say a planet is Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and any of the 5,000 other objects like them that we found orbiting other stars.
Thank you.
Parker Goodwill, 8th grade, and is the space station in our atmosphere or in outer space?
Well, it depends on the definition of an atmosphere, but most definitions say the Earth's atmosphere goes up about 62 miles. Actually, half the weight of our atmosphere is within the first 3 miles of the ground, so that's kind of cool. Since the space station is higher than 62 miles, then, at least based on that definition, it is in outer space.
Thank you.
You're welcome.
My name's Gavin McCauley. I'm in 7th grade, and my question is, what do stars look like in space?
So when you see a star, has everybody seen stars twinkle? You know what, when we say twinkle, the best one to look at is if you go out, if we actually get some clear weather provided by our friends here from meteorology. If you can go look outside on a nice clear night and see the star Sirius. It's the brightest star in the sky, and it twinkles more than any other. And so if you look at Sirius, it'll look white, then it'll change to blue, then it'll change to red, and it'll look like it's kind of winking at you on and off. And that behavior of stars is because the light has to pass through the Earth's atmosphere. So up in space, coming back to the last question, we're up above most of Earth's atmosphere. So if you were in the space station or you were in another vehicle looking out at the stars, you would not see the stars twinkle. So they would appear much steadier. It would just look like a steady brightness. They would not appear to change color. They would appear to have a very steady color, but they wouldn't look otherwise different to us than they do from Earth. They would be little tiny points of light because they're so far away that we can't see them as the real large objects they really are.
Okay, thank you.
Sure.
Hi, my name's Cooper, and I'm in 7th grade, and I was wondering if we're ever going to be living on Mars.
You guys.
All I can say is maybe. Let's see if the astronomer knows something.
So usually when I get this question, the thing I like to bring up is not so much living on Mars, but getting there. And so I wonder if the astronauts are going to tell you something about this. Space is really dangerous, and it's really bad for people. If you're up in the space station, you're protected as best we can, but when astronauts land back on Earth, they've absorbed so much high-energy radiation from the sun that they're at a much higher risk for a lot of diseases than we are. So I've met one astronaut, and he mentioned to me that his chance for getting cataracts in his eyes is about 500 times larger than yours will be because of the time he spent in space. And so living on Mars is going to be very tough. We have to figure out, how can we create some kind of habitat for humans, but getting there is even worse, right? And I hate to sort of take all this enthusiasm and excitement and talk about morbid things, but right now, if we sent an astronaut to Mars, they would arrive dead. So we do not have the technology to get a human safely to Mars. So we can't figure out, well, I mean, we can work on it, but we're not so much working on the living on Mars until we solve the getting there first part.
Thank you.
My name is Sydney. I'm in 6th grade, and I was wondering if astronomers talk to aerospace engineers often.
So I'm an astronomer. I talk to a couple of aerospace engineers from time to time. So let me say, what do astronomers do? We study space, and we study the objects in space. And so the way we study the objects in space is often with telescopes or with robotic missions. So we've sent robots to orbit around Jupiter. We've sent robots out to fly by Pluto. Those robots were designed and built by aerospace engineers. But if you say, what were they building? Like, they worked with a team of astronomers who said, I want to study Pluto. Here's what I need on a satellite to collect data that will teach me about Pluto. So it's a team of scientists and engineers working together to define what the questions we want to answer, and then the engineers build the systems that will answer those questions for us.
Thank you.
Sure. Could answer the same thing about media logic.
Hi, my name's Aiden O'Shea. I'm in 8th grade. And how much does the weather affect the timing of launching a rocket into space?
Good question, Aiden. NASA has something called launch commit criteria that does take weather into effect. Kind of goes back to the Challenger disaster. If the temperature is too low or too high over a certain period of time, they scrub the mission. If the winds are too strong at the launch pad and it's dangerous for the crew that sets up the flight, they scrub the mission. If there's a strong change in wind speed with height, that could cause stresses on the shuttle or on the spacecraft that could cause an accident, they scrub the flight as well. Lightning, rain in the vicinity, clouds that produce ice that would change the aerodynamics of the rocket also can cause them to scrub the mission.
Yeah, NASA has at least 8 criteria relating to thunderstorms where they can't launch. You have to have lightning. Lightning can't be within a certain distance because like the Apollo 12 rocket, when it was launched, it actually got struck by lightning on its ascent, but the crew was able to reset the instrument panels in enough time so they could safely make it into space. And alluding to what he said with the Challenger explosion, the O-rings had some problems because of the extreme cold and it iced up, but actually what happened, if you look at some of the video, as the rocket was going up, aluminum oxide kind of helped seal that initially, but then it encountered some extremely strong wind shear, which is a change in wind direction or wind speed as you go higher up in the atmosphere. And it jostled the connection enough that even the temporary seal that the aluminum oxide made got broken up and allowed the flames catch up, and that eventually led to the explosion. But without that wind shear, there's a possibility that the Challenger could have made it even with the O-ring failure. But so there's a lot of criteria that can go in, and like you said, with ice, they don't like to launch rockets through clouds because of, especially if they're go below freezing temperatures, because ice can have detrimental impacts on the rocket as well.
Thank you.
Thank you.
Yep.
That wraps up our questions from our students. Do you have any final comments that you'd like to share with our school before we move on to the next portion?
Is there anybody here who really gets excited by bad weather? Big snowstorm? Okay, okay.
Snow days, maybe,
Not
2-hour
snow days,
delays.
So if you want to go into science, what course do you think you should work the hardest on in middle and high school? Just yell it out. What do you think? Science is 1. There's one more.
I heard it.
There's a lot of math. So challenge yourselves in school, and you'll set yourselves up well.
That's a great point.
Is that good? All right. Thank you.
Thanks, guys. Okay, thank you, everybody. While we're getting set up here for the next portion, there is a test today. I don't know if your teachers told you that. So, anyways, just real quickly with a show of hands, how many of you are in the Bellefonte Middle School? Okay, so students, now keep your hands up. Students, I want you to pay close attention. All the adults in the room forgot that they're in the middle school today. Okay? All right. So now that we have that out of the way, I think everybody that's here should really be here, right? Okay. Next show of hands, how many people were involved in this project either through learning in the curriculum or in extracurricular things, either building parts for the antenna systems or being involved in some other way? Show of hands, how many people were directly involved in this in some way? Learning in your classrooms? Come on, I know you were in there.
I think just about every science classroom talked about something, maybe your English classes.
All right, yep. So
Art students.
All right, good job. Okay, thank you. All right, well, so this next video will highlight some of that. So again, when the house lights go down, we'll start the video, but it's just a short 3-minute video, and it focuses on the participation and preparations that all of you put into making this event possible. So here we are. So again, a lot of hard work from all of you, and thank you for all of that. So this last video here is the Meet Your Astronaut series, and the astronaut, as you know, will be Mr. Scott Tingle. We'll be speaking with today, or at least trying. And this is about an 8-minute video of his journey into space, very much condensed. It takes several days for this to happen, but it'll begin with his launch off of the pad in Kazakhstan, and end up with him arriving into the International Space Station. So this will be our last video.
And with that, we see the fires lit, the engines start to roar, and lift off. Scott Tingle, Anton Shkaplerov, and Norishiki Kanai on their way to the International Space Station.
Just about 10 meters separating the Soyuz and the station. Closing in, standing by for contact and capture of the International Space Station. Contact confirmed.
Contact confirmed.
Capture confirmed.
Copy. Now we have
at 2:39 a.m. Central Time, 3:39 a.m. Eastern Time. And the Soyuz hatch now swings open at 1:55 p.m. Moscow time, and Scott Tingle of NASA makes his way into the International Space Station for the first time.
On behalf of the United States and the American people, let me just tell you all how delighted we are and how pleased I am to be able to congratulate you on this momentous occasion with Mission 54. I have to say we've got 3 great Americans, we've got friends from Russia, we've got a great friend from Japan who are part of this mission, and it's such an honor to go Marine Corps, go Army, and I have to tell Captain Tingle that I was watching the faces of his family members as that hatch opened, and it brought a tear to my eye. It was the most special thing being here and feeling the emotion. Everyone is so proud of you. We congratulate you on what you're doing, not just for the people of Russia, the United States, and Japan, but for the people of the world. Congratulations.
Thank you, Rob. Thanks a ton. That's incredible.
It's obviously exploring new and distant places, and but at first, I mean, that's when you're younger, that's what I wanted to do. I saw Neil Armstrong walk on the moon, and I looked at my mom and said, hey, I want to do that. I had to create my own opportunities, and so when I got my first job when I was 9 years old, and then I was working pretty much full time by the time I was 14. And if I wanted a bicycle, I had to go find the parts, put it together, and make it work right. So I did that. Not only was it a good bicycle, but it was the best bicycle in the neighborhood. It could ride wheelies, and it could go over jumps, and ride through the woods. It could do, and I did everything on that. I graduated high school from Blue Hills Regional Vocational Technical High School, just south of Boston, Massachusetts. Really good experience there, working with a lot of machines and technical design and things like that. And, got a lot of after-school jobs doing technical things, so it was a really good experience. Moved on into engineering at Southeastern Massachusetts University, now called University of Massachusetts. They changed over in mechanical engineering. Again, another great opportunity. Had some great mentors there, folks that I still keep in touch with to this day, professors, deans, all those folks, presidents, all those folks that run the school. Just a great facility and great people. Then I moved on to Purdue University, again in mechanical engineering with a specialty in fluid mechanics and propulsion. And I cleaned a bakery at night, between midnight and 6 in the morning when I was just getting into high school. And then graduated that opportunity up into actually making bagels and bread and things like that. And all of that funded my first year or two of college, and without which I would not have gone. And so at a young age, I realized that if I wanted to get somewhere, if I wanted to get to be an astronaut, I was going to have to start working early and hard to make it happen. In college, we had a very tight engineering group, and it was so tight that we started pulling people in from other disciplines, computer science, business and things like that. The camaraderie was absolutely incredible, and the support that we gave each other was absolutely incredible. I did a little bit of Kung Fu for about 3 years there because it was active and it was physical and it was something different that I wanted to try. I was in a rock band, played lead guitar all the way through college. We had several gigs in and out of Boston, Providence, up and down the East Coast there a little bit, and that was actually a pretty good team activity too. I actually enlisted when I was 18 years old, and I spent my summers going to training in Chicago and Japan and some other places wherever my unit deployed, and then I did 1 to 2 weekends a month. Yeah, every Navy squadron and Air Force squadron, they have names. They have 14 squadrons, Jolly Rogers, the Top Hatters. Those are all F-18 squadrons now, by the way, because F-14 went away. But at VX-9, they called themselves the Vampires, just because that's just what they were. We did a lot of testing of systems and vehicles at night for missions that no one would see. I want to see what's over the horizon. I want to see new places. I want to meet new people. I want to create new technology. I want to be part of the future. I want to have an impact on the future. I've had the opportunity to do a lot of great things in a 30-year career, engineering, flying airplanes, and now here with NASA. And the groups of people that I've worked with have been absolutely incredible. Well, the one consistency across the board is that they have provided me with a lifetime of inspiration. So I grew up in the town of Randolph, Massachusetts, kind of a small town, and the folks at home knew how driven I was. They knew how interested in science, engineering, and space flight I was, and they were nothing but supportive the whole way. There's literally thousands of people that I've worked with in my military career. Absolutely unbelievable. Some of the most inspirational young Americans you'd ever meet in your life. You'll walk down in the bowels of the ship and you'll see these 18, 19, 20-year-olds covered head to toe in grease, just coming off a 24-hour shift so that we could fly our airplanes safely and efficiently. Absolutely inspirational. When things get hard for me or challenging, I think of those folks, and it makes me want to do better. And that's one of the things that I'm finding is very consistent throughout my career. When I came here, we've got civil servants, we've got contractors, we've got military, you name it. And we all have one goal, one mission, and watching the team work together is just inspiring. My ultimate inspiration is the love and support I get from my family. They've been so solid over the years that there's absolutely no way I could be doing all this without their support. I'm Scott Tingle, and I'm a NASA astronaut.
Okay, thank you everybody. We'll just take a few minutes here to get the stage ready with the amateur radio team will be coming up. And you all can stay seated for a moment till we get a little bit closer. We'll have some time to fill in here. So a little stage change and we'll be right with you. So now's the time to talk and get it out of your system if you need to do that. So you all have figured out that the right-hand screen is the live stream that's going out to the world. And I was just checked into the chat window that is with that, and there are Bellefonte alumni, students, and staff watching all the way from Arizona today. So it's kind of cool. There are people watching from around the world. Yeah. Okay. All right, so feel free to wave there as long as they're willing to keep you up there on the screen. Of course, the image on the left-hand side here is the astronaut that we're going to try to speak with today, and you saw in the videos, Mr. Scott Tingle. And the center screen probably needs a little bit of an explanation. So I'm assuming that you all are up to speed on your geometry, or geography. And you see the North American continent there and the United States. And you see that shaded gray circle that's coming across the United States right now? The plus sign in the center of that circle is the International Space Station. And that circle represents the horizon at which point the space station will be visible. So the plus sign over there about where Pennsylvania would be, that's our location here where the antenna is located on top of this roof. When the gray area reaches the edge of that plus sign where Pennsylvania and Bellefonte Middle School is, at that point we should start calling the space station and hopefully hear them in return. Down at the bottom of the screen, you see from right to left, there's a 63, and a little further in it says AOS, and it shows 4 minutes. That means that in about 4 minutes, we will have acquisition of signal and should be able to communicate with the space station. So those are the things we're going to want to watch. So I have to give a little shout out here to where's Mr. Ecker's class. In case some of you may not be aware, Mr. Ecker's class built the base for the antenna that sits up on the roof. So hopefully that'll hold together today, guys. Good job building that antenna. All right, so slowly making its way across. It looks like we're getting into the Dakotas, North and South Dakota there, it looks like, with the space station. 3 minutes to go, 3 minutes to contact. Okay, students, if you can come up now, make your way up here and be ready.
Testing. Can you hear him out there? Testing.
One minute to go, so we're getting close here. All right, so now listen up, guys. We're getting close enough here. So what you're going to hear, hang on, guys. What you're going to hear is Woody Brem over there will make the initial contact. We'll try from both directions until we can establish that we do have an active two-way link to the space station. And then at that time, Woody will turn it over to the first student, and we'll begin our questions. So,
gentlemen, during this time, it is incredibly important that there is no talking, just as we talked about this morning. There's no talking while we're in this portion of the program. Think about how big of a deal this is that we are about to talk to an astronaut on the International Space Station. We need to make sure our radio crew over there can hear everything they need to hear. So we have 15 questions and only 9 minutes to do this. So very little window to make sure we get in all of our questions. So please make sure you are not talking to your neighbors throughout this event.
Thank you, Mrs. Garman. Okay, so you see it's at 0. Now we're waiting for the elevation. Because we live in the valley, where the space station is coming up here to the north, we have to have them at an elevation of about 1.5 degrees above level before we can get them above the mountain and communicate. So right now we're at 0.2 of a degree and climbing. There you see their horizon is just touching the Bellefonte Middle School. And we have squelch and audio there from the 746. Okay, there's 1.2 degrees, so let's give it a try.
NA1SS, this is Whiskey 3, Yankee Alpha. NA1SS, this is W3YA. NA1SS, this is W3YA.
Yankee Alpha, this is November Alpha 1, Sierra International Space Station on Channel 40. How copy?
Roger, Roger, we got you 5 by 3, 5 by 3 Bellefonte. NA1SS, this is W3YA. NA1SS from W3YA. NA1SS from W3YA.
Whiskey 3, Yankee Alpha, this is November Alpha 1, Sierra on Channel 40. How copy?
All right, Scott, we copy you 5 by 9, full quieting in Bellefonte. Good afternoon. NA1SS. NA1SS from Whiskey 3, Yankee Alpha. NA1SS from W3YA, we copy you 5 by 9, Bellefonte. All right, please proceed.
I am asking this question on behalf of Sam, 8th grade. Is there a specific task that astronauts have to relearn how to do because the normal way is impossible with zero gravity?
We have to relearn how to do in space.
This is Nash, 7th grade. How many more years will the International Space Station be active to help astronauts find out about space?
Hey, Bellefonte Area Middle School, that last question did not come through. Please repeat.
This is Nash, 7th grade. How many more years will the International Space Station be active to help astronauts find out about space?
Bellefonte Area Middle School. It appears something may be wrong with your microphone. I can see that I am receiving a signal, but there is no side tone and no voice. Whiskey 3 Yankee Alpha, November Alpha 1 Sierra Sierra on channel 40. I am no longer receiving in Bellefonte Area Middle School. I see good bars on my receive, but no voice.
November Alpha 1 SS from W3YA.
So it appears he can see that we have a signal going up, but for some reason he can't hear that signal. So we're not sure at this point. It appears that everything's working fine here, and there might be a problem up there. So we'll bear with us. We'll do the best we can for the time we have left.
Whiskey 3 Yankee Alpha, November Alpha 1 Sierra Sierra International Space Station on channel 40 in the blind. I do not hear any voice coming from your signal.
Anyone SS from W3YA. Anyone SS from W3YA. Alrighty, stand by for next question.
This is Nash, 7th grade. How many more years will the International Space Station be active to help astronauts find out about space? Over.
All right, thank you.
This is Emma, 6th grade. What is the average age astronauts begin training for space travel? Over.
The average age that astronauts begin for training for space travel is around 30 to 35.
Thank you. All right, thank you. Next question.
This is Bailey, 6th grade. What was the scariest machine malfunction that has happened to you, and how did you fix it?
I think we have an antenna problem. All right, thank you. Next question.
This is Madison, 7th grade. What was the most stressful thing you had to deal with while being in space? Over.
The most stressful thing that I had to deal with while being in space was that it was a new environment, and I just needed to learn how to think and think naturally on how to move around and how to eat and how to do all the natural things we do as humans. Over.
Thank you. Next question.
This is Caitlin, 8th grade. Which common misconceptions about space do bothers you the most when people speak of space?
I think the biggest misconception about space is that it's lonely. And it is very dark sometimes, and there's not a whole lot of people up here, but it's very exciting and very beautiful. I do not find it lonely at all. Over.
Thank you. Next question.
This is Cecilia, 7th grade. Do you notice any significant changes to your mood and stress level? If so, what are some coping mechanisms you utilize? Over.
I actually find being in space is very calming. I enjoy it so much, and I get to work with lots of my friends on the ground and my friends up here on the International Space Station.
Thank you. Next question.
This is Ian, 6th grade. Does the lack of gravity take a toll on your body? Over.
NA1SS from W3YA.
Okay, well, as you can see from the map, there were a few technical difficulties. It is space. Okay, so they're beyond the horizon. So, to all you students that are still up here, this is space, this is the unknown, so we did have to roll with the punches. I'm very sorry that it worked out that way. So have a good spirit, and thank you very much. All right, let's have a big round for these kids. All right, so just to let everybody know, so we've done this several times now and had excellent signals with no issues as they passed overhead for several other school contacts, but today seems that the dice were stacked against us. So, but we did get here Mr. Tingle from space, and that's pretty exciting. So a big round of applause for Mr. Tingle. Okay, and from there, I will turn it over to Mrs. Garman. I think she has a few words to say. And let's have a big round of applause one more time for our Whiskey 3 Yankee America and our radio team. Okay, with that, Mrs. Garman.
All right, so I know that it didn't go exactly how we thought it might go, but we still got to speak to an astronaut in space. Something that no other students in this area can say that they got to do today. So congratulations to all of you, to all of the hard work that you've put forward, to the staff and all the members of our community who have donated their time and their money to make this happen. It truly has been an incredible team effort. And again, one more round of applause to our amateur radio group. Our school made history today. No other Bellefonte Area Middle School student before you has had this opportunity, and I don't know if any other Bellefonte Area Middle School student after you will have this opportunity. So I hope this is something that each of you remembers for the rest of your life. Thank you so much for your participation and for everything you've done to make this happen. And at this time, 8th grade, you are dismissed.